Hi everyone and welcome to the Global AI On Tour in Melbourne. Today I'm going to be talking about getting started with the Composer for Bot framework. My name is William Liebenberg. I'm an SSW solution architect here in Melbourne, and my developer journey started in 1999 with C++. I moved over to .NET and C# around 2004, and along the way I fell in love with Azure and I've been using it ever since. You can find me on Twitter, LinkedIn, or at my blog site azuregems.io. Now, when talking about bots, people tend to imagine this kind of character. It's got arms and legs, it can move around, we can talk to it, it can understand us and talk back, and even perform some actions for us. Now, the software that drives this character can also drive this interesting contraption. We're taking the readings and measurements from the real world and interpreting that inside of our software to then generate another response or perform another action. So why would we want to then develop bots? So we develop bots to sort of perform the repetitive tasks that, uh, as humans, we don't like doing. We get tired or if we get fatigued and we get bored. Whereas bots, they don't complain. They can do the same thing all day long, and they can actually do it much faster than what we can do. Now, we also developed bots to sort of mimic or even replace our human behavior. So that when we interact with them, we have a sense of familiarity and not just some cold hunk of metal. Now, bots can scale because it's software, right? So we can just, if we need to do more work elsewhere, we can just deploy more and more copies of this bot and get more work done. So what we're going to be looking at is the conversational software that we can use to converse with these bots and get some responses back from them. Now, bots are everywhere. So imagine a search bot where, given a question, it can go off and mine a huge mountain of information and come back with an appropriate response. This is like the digital assistants we have in our homes now. So Cortana, Siri, Alexa, and Sophie. We can ask them questions like, what is tomorrow's weather going to be like? Or what are the top news headlines? And they can give us the answers right away. And we do all of that through conversation, whether it be via text, audio, or video. It's pretty cool now because we can walk into a room and via video, a bot can recognize us and proactively start a conversation. So we don't have to initiate the conversation anymore. That's pretty cool. Now, there are some serious challenges that we have to overcome when developing bot technologies. For a start, human conversation is very dynamic. We don't often repeat sentences exactly the same way that we have previously, and the small nuances in our language can actually slightly change the meaning of what we just said previously. So when building bots, we have to take this into account so that when the bot needs to go and perform a task, it does the right task. It doesn't go and do the wrong thing at all. So that is the first challenge. The next one is that humans make mistakes, whether we like it or not. So do we then have to carry those mistakes into our bot development? And do they have to perform the same mistakes we do? And that's a serious challenge because do we want them to, when they're responsible for our safety in the workplace or in our self-driving cars, do we want them to make those same mistakes as we would? So that's an interesting challenge. And understanding humans is hard. That's why we argue with each other. We disagree on some things. But when it comes to dealing with bots, well, we don't want to give a bot a task and all of a sudden it starts arguing back and refuses to do it for no good reason. And we want to keep the system simple enough so that it can understand us clearly and go and do what we ask it to do. And this is where the cognitive services come into play. So these services sort of replicate human abilities and human senses so that we can use them and bolt together a bot that does exactly what we need it to and using the senses we need it to utilize. So when mixing bots and AI or cognitive services, we can give them the ability to see. Now, we can use the Azure Vision API to recognize a scene or an object in a scene. You can even use the Face API to recognize our emotions to know whether we're happy or sad or just content. And we can then make the bots give them the ability to hear. So we can turn speech into text and feed that text into a natural language processor such as Lewis so that the bot can understand us. We can then take it a little bit further by taking that very same text and running it through text analytics to determine the overall sentiment. It would be useful in the case of a customer service bot to know, hey, this customer is happy or is very upset, and it can change the conversation flow to get the customer back onto the happy path. And that's very interesting. It's very, very useful. We can finally also give bots the ability to speak. We can use speech synthesis or SSML, but it's quite involved. But once you get it done, it's pretty awesome. Now, there's one sense missing from this list, and it's the sense of smell. Now, there's some serious research going on in this area, but I doubt it's going to make it into the cognitive services anytime soon. So when we come to developing a bot, I often choose the Microsoft Bot Framework, but there are other choices out there, such as Lex or Dialogflow or even BotKit. Essentially, they all let us do the same thing, which is build conversational software and attach our AI experiences to it. And once we've built and deployed our software, we can interact with it mainly via the web or via some of the popular chat platforms such as Teams, Skype, WeChat, etc. So when it comes to developing a bot framework application, web developers will be right at home because it's very much just like developing a web API. The controller maps to the activity handler, and action maps into intents, which we'll cover shortly, and parameters maps to entities. And we still have to deal with the usual development headaches, such as dealing with bugs. We have to write tests and take care of DevOps so that we can deploy our software and monitor the health and performance of the software out in the field. But is there an easy way to do all of this? Sometimes it takes a fair bit of work to get all of this set up. Yes, the Composer for Bot Framework definitely makes a lot of this very easy. It's open source for a start. You can find it on GitHub, and it's a dedicated IDE for building bots. So it allows us to, without any code, visually program our bot and build up our conversation flows. So we can string together a bunch of actions and add some branching in there to build complicated business logic. And we can build a nice, complicated conversation, but quite easily. And we also get all the sort of cool tools, such as the language generation and the response systems, so that we can train the bot with the right information. And once we give it a question or an instruction, it can give us back a really rich response. We also get to train the whole tool chain for training the Lewis and Q&A makers all built into the Composer. So we don't have to then jump outside of this tool to get that done. And finally, it can also take care of the DevOps issues for us by simply just deploying our bot to Azure for us. So if we open up the Bot Framework Composer, this is what you'll see. We've got an intent selected there, the weather intent, and once that's been triggered, you can see that the bot will say to the user, hey, let's check the weather. It will go and ask the user, what is your zip code? And once the user has supplied that answer, the bot will remember it and send back a response right away and say, all right, let's check the weather for your zip code. The bot then goes off and sends a HTTP request to a weather service. So that's pretty cool. So, just with one simple action, we can make a HTTP request and get back a response. And then we can branch off and say, hey, was this response successful or did it fail? And then we can send back the appropriate message to the user. So in the workflow of building a conversation with a bot, we start with the language understanding. So we have to supply some utterances or sentences to the bot. And we have to then identify the intent and break down into entities so that once we train the bot and give it other sentences or utterances, it knows how to recognize them. So if we start off with the sentence, how's the weather in Melbourne? We can label this with the get weather intent. And we can highlight Melbourne as an entity and give that as the location entity. So once we've trained the bot with the sentence, the next time we ask it the question, how is the weather in Sydney? Then it still understands that this is the get weather intent, but the entity or the location entity is Sydney. And then it'll pass that to the weather API to get the weather for Sydney. So then once now we get into the dialogue flow or the conversational flow between the bot and the user, we can see that we can build some business logic in here, make some decisions and build a nice, rich or a complex conversation. So we can see, hey, the response, did it fail or was it not a 200 status code? If it was, then we can send an error back to the user saying, hey, I got an error with the error response from the API. Otherwise, if it was successful, we can save the weather response, keep it for later, and we can straight away send back the weather response using the response templates, which we'll see in the next slide. So this is one of the response templates. So we have a string here that is got a couple of templated fields, the sky condition and temperature. So the response we got back from the web API, we can use the values in there to substitute these placeholders in the template and generate the final response. So the bot can say, it is sunny and 32 degrees. It's awesome. So we can store multiple values or objects in the bot's memory. And even though they've been collected multiple steps previously, we can use them anywhere in the conversation when it's appropriate. It's pretty cool. So let's quickly jump into the bot framework composer and see how it works. Okay, so we've gone and cloned the project from GitHub and run through the build and install instructions. And now we can see that the composer is running on localhost port 3000. If we go there, this is what we see. So I've already built the weatherbot example. When I open that up, we see that I'm using Lewis, which is the natural language processor. I also have a couple of dialogues. The first one is a greeting dialogue. So when a user joins the conversation, it says welcome. And then we have the get weather intent. Now I define that intent with a few phrases. And I also then highlight or extract the entities in that phrase that I want to use later on in the conversation. So we can see from our canvas here that straight away I'm sending a response to the user to say, let's check the weather for your city. I can also set a property into the bot's memory, particular properties such as user.location via an expression. So in this case, I'm just reusing the same city entity, but you can modify this in any other way. Now, next I'm sending a HTTP request to a weather API, and I'm using the user's location as one of the query parameters. Once I get a response from the API, I can check the result by, can write a condition expression here. And if it's a success error code or a success status code, then I can send back a nicely formatted message to the user with all the weather information. Otherwise, if the response status message was not okay, then I can send back a nicely formatted error message. And also at the end, I can send a closing message, which is one of multiple sentences that the bot framework composer will choose for us to add a bit of variety to the dialogue. So if I start this bot and open it up in the bot framework emulator, we can test this bot locally. Okay, so now we can see here, got some debug information on the right-hand side and our conversation window on the left. So straight off, we get a greeting message from the bot, and we can then go, what is the weather in Melbourne? So the bot now knows, it's going to check the weather for Melbourne. The weather is, rain is easing with a maximum temperature of 16 degrees. I hope you enjoy the weather in Melbourne. Cool. So let's try one more. What is the forecast for Sydney? So using a slightly different variation of the question. It still can pick it up, picks up Sydney as the entity, calls the API, and gets back a response that says the weather is mostly sunny with a maximum temperature of 21. Have a nice day in Sydney. So you can see here that our closing message is a slightly different version. And at the same time, we can see all this rich debugging information on the right-hand side, so we can dig in to see what happens with our conversations. And in a nutshell, that is the bot framework composer. You can develop bots without actually having to write any real code. All right, so we just saw how the bot composer works. And to finish off, here's my 5 top tips to building better bots. First, make sure that your bot does one job. Don't try and build a bot that does absolutely everything. You'll run out of money and then energy, or both. It's not worth trying to build a bot that does everything. Next is make sure that whatever your bot does, it can do it better and faster than a human. Otherwise, there's probably not much reason for you to be building that bot. Make sure though that when your users are interacting with your bot, they know it's a bot and not a human. People might get a little bit spooked out halfway through a conversation when they realize, hey, this is a bot, it's not a human. Either they'll walk away or they might start swearing at your bot. It's probably not the experience that you're looking for. Then make sure your bot has some basic intents. It can understand greetings from a human and that it can actually greet the human back and immediately say, hey, I'm the weather bot or I'm the pizza ordering bot. The user would straight away know what to expect from this conversation. And make sure that your users can ask for help and that the bot can respond with what it can do for the user. And finally, if conversation sort of is going nowhere or the user is confused, they can say cancel or reset so that you can try again. And finally, give your bot some personality. Let all the responses be sort of happy or even comically grumpy, but as long as it's a great experience to end user. And with that, thank you for watching.